Now, last but not least, we have to do the Hamiltonian method. Okay, what's step one for the Hamiltonian method? Write the Lagrangian, which is L equals T minus V. As we have done above here, I'm just going to copy my Lagrangian over, which is 1/2 M1 plus M2 plus I over R squared X dot squared plus M1GX plus M2G L minus pi R minus X. Step number 2, write the generalized momentum in terms of coordinates, and the expression looks like partial L over partial Q dot equals P. So in our case, what is a generalized coordinate? X dot. Very good. So it'll just be partial over partial X dot equals P, or M1 plus M2 plus I over R squared X dot equals P. Step number 3, re-express. So that will give me X dot equals P over M1 plus M2 plus I over R squared. Step number 4, write the Hamiltonian as the sum of Q dot P I minus L. So this implies I have to write H as X dot P, since we only have one coordinate, minus L. So I need to now replace every single spot with. Step number 5, I have to rewrite the Hamiltonian in terms of just momentas and position. So that means I have to replace everywhere I see X dot with this expression. So my Hamiltonian will now become P squared over M plus M2 plus I over R squared minus P squared over 2 M1 plus M2 plus I over R squared minus M1GX minus M2G L minus pi R minus X. So that implies my H will become X dot P minus a half M1 plus M2 plus I over R squared X dot squared minus M1GX minus M2G L minus pi R minus X. So then I will also replace X dot here, X dot here, wherever I see it. which means I can rewrite the Hamiltonian as P squared over M1 plus M2 plus I over R squared minus P squared over 2 M1 plus M2 plus I over R squared minus M1gx minus M2g L minus pi R minus x. Or the Hamiltonian could be written as P squared over 2 M1 plus M2 plus I over R squared minus M1gx minus M2g L minus pi R minus x. This is the Hamiltonian expression that we were looking for. Step number 6, write the Hamiltonian canonical equations. So the generalized form will be partial over partial P dot Q dot and partial H over partial Q equals minus P dot. For our scenario, this will become partial H over partial P equals X dot, and partial H over partial X becomes minus P dot. So if I use equation here, which I'm calling equation 1, what will I get? P over M1 plus M2 plus I over R squared equals X dot, and minus M1g plus M2g equals minus P dot. So coming over to this side, can I differentiate with respect to time? So what will I get? P dot divided by M1 plus M2 plus I over R squared equals X double dot, which means I can plug this value in here. So the expression becomes M1 minus M2 G divided by M1 plus M2 plus I over R squared equals A, which is the same expression again, except this time we were using the Hamiltonian method.